Hello, this is the Further Maths Support Programme in Wales, providing you with a worked solution to question 14 on the June 2018 higher Unit 2 paper. So Unit 2 is the calculator paper, and it's about measure, and it's about arc length in a circle. And here is the question. A and B are the points on a circle with centre O. Calculate the length of the arc AB shown below. So what is our thinking on this? Well, it's a 2-mark question, so hopefully not too much thinking. One is that we think about what would be the arc length of a full circle, and we know the formula for that's the circumference, is twice times 2 times pi times r. So this is a useful technique for any problem solving, not actually just this exam question. Sometimes you've got a problem and you think, okay, what simpler problem could I solve? So a simpler relevant problem is that we can easily find the arc length of a full circle using the formula 2 pi r. And then to get from there to the answer, well, the angle at the center is 191 degrees, and the arc length scales proportional to the angle at the center. So the proportion of the full circle needed is 191 over 360. Okay, let's have a go at it. Okay, let's work through the solution. So first up, we know the circumference is twice times pi times the radius, which, given the radius is 3.1, gives us 6.2 pi. And we don't have the entire radius in this arc, so what is the length of the arc? Well, as we said on the previous slide, it's 191 over 360 times the circumference. And then using our calculators, we can either get that as 10.334, or if we're keeping it in terms of pi and using fractions, we could have 5921 over 1800 pi, or the decimal equivalent of that. And then finally, given they gave us the radius to 1 decimal place, it's reasonable to round it to 1 decimal place in the answer, so 10.3 centimeters, or we can give the precise answer in terms of pi as well. Okay, that's it. One final check is this reasonable? It's always good in maths just to check it's at least plausible. So this is roughly a radius of 3, so 2 pi r is going to be twice times 3 times 3, it's a bit bigger than that, so that's going to be about 18. This angle here is close to 180, so we're looking at something a bit bigger than half of 18, a bit bigger than 9, because 180 would be a semicircle. So we're looking for something a bit bigger than 9 centimeters. 10 centimeters, 10.3 centimeters sounds about the right value. Had it been in the hundreds or very small, then we would take a serious look at our calculations. So in this case, it's reasonable, so we're done. So here we have an alternative question, also about arc length, and what we have is points AB on a circle center O, radius 1.1 r. Okay, so a thing to notice is that normally we think of r as representing the radius. They've given us a radius which is 1.1 r, where r is some quantity, so we just need to be careful that doesn't trip us up. Similarly, the second arc, points C and D, are on a circle center Q with radius 1.3 r. It says calculate which of the arcs shown, AB or CD, is the longer. Now, our thinking, the basis for our calculation, is going to be very similar to what we did in the original question, that we can calculate, for instance, on the left hand side, the circumference of the entire circle, so it would be twice times pi times the radius, where the radius is 1.1 r, and then we need to scale that, take 217 over 360 of that. Similarly, we can do that on the right hand side. We have a 1.3 r, that's the radius, times 2 pi would be the entire circumference, and we scale that by 184 over 360. Now, in neither case will it be a pure number. They'll both involve r, but we will be able to see which one is the longer. So let's see that happen. So AB is 2 pi times 1.1 r times 217 over 360. CD is 2 pi times 1.3 r times 184 over 360. Whereas, emphasize again, r is not the radius. They're sort of messing with our minds, giving us an r involved in the radius there, but we just need to be careful, just need to not get confused. If we then calculate both of those using our calculator, we either get 1.326 pi r centimeters for AB and 1.329 pi r centimeters for CD. So we can see that CD is longer, or equivalently AB is the shorter. So we've answered that. Final question, good on all maths, is this reasonable? Well, let's have a look. We can see that as we move from the left diagram to the right diagram, we've increased the radius by roughly a little less than 20%, and that has a tendency to push the arc length bigger. We have decreased the angle at the center again by sort of 20%ish, which has a tendency to make the arc length smaller. So we've got two effects which roughly cancel each other out. So it's certainly reasonable that the figures are close to each other. It's very hard to have an intuition as to which one would be the larger, but it certainly looks sensible what we've done, so we're happy with that, and we've answered that, so well done us. Okay, that was a work solution by the Further Maths Support Programme in Wales to question 14 on the June 2018 Higher Unit 2, so Calculator GCSE, and it was about measure, in particular arc length in a circle.